This video will be over factoring quadratics. So example 1, we have 2x squared minus 2x minus 24. What we need to look for first is a GCF, the greatest common factor. So if I look at 2x squared minus 2x minus 24, I notice that all three terms are divisible by 2. So that makes my GCF equal 2. So what I'm going to do is I'm going to divide everything by 2 and factor out a 2. So when I do that, I get 2 times, and then I write down what I have left over. So 2x squared divided by 2 is just an x squared. A negative 2x divided by 2 is a negative x. And a negative 24 divided by 2 is a negative 12. So I factored out my GCF. From here, now I need to factor the trinomial that's inside the parentheses. So I call this the x in the box method. The x helps us organize our thoughts. The box helps us factor. Okay, so I draw my x in my box. So to get the top of the x, I take my first term times my last term. I'm multiplying. So x squared times a negative 12 gives me a negative 12x squared. Then my middle term goes on the bottom, so a negative 1x. So I have to ask myself, what can I multiply to get the top? So multiply to get the top and add to get the bottom. So what I'm going to do is I'm going to list all my multiples of 12. So I have 1 and 12, 2 and 6, 3 and 4. So I need to know what can I multiply to get a negative 12, add to get a negative 1. Well, if I try to add or subtract 1 and 12, I won't ever get 1, so I mark it off. If I try to add or subtract 2 and 6, I won't ever get 1. But if I look at 3 and 4, if I make the 4 negative, 3 plus a negative 4, I get a negative 1. So my side parts, I put 3x and a negative 4x. Okay, now that's just organizing my thoughts. Then I go to the box. My first term goes in the first spot in the box. My last term goes in the last spot in the box. Then my two missing terms, okay, are going to come from the sides of the x's, the 3x minus 4x. And if you notice, 3x minus 4x gives me that middle term right here. Now, I'm looking at my common factors. So if I'm looking at x squared and 3x, what do they have in common? Well, they are both divisible by x. So I write an x up here. And then I ask myself, what can I multiply x by to get an x squared? Well, x times x gives me x squared. So it's the opposite of the box method for multiplying. Then x times what gives me a 3x? A positive 3. X times what gives me a negative 4x? I get a negative 4. And then if I want to check this last square right here, okay, I multiply 3 times negative 4 and I get that negative 12. So my factors are these side parts right here. Okay, so I have x plus 3, x minus 4, and then I have my greatest common factor I can't forget about. I put that on the outside. And there's my answer. If I wanted to rewrite it, okay, this is also correct. Okay, remember that multiplication is commutative, so you can move it around. So it does not matter if you put the x plus 3 first or the x minus 4 first. They are the same thing. Moving on to example 2. I have x squared plus 11x plus 24. If I'm looking, first I always look for a GCF. This one, it does not have a GCF, so no GCF. Okay, then I go straight into the x in the box. So my x, my box. To get the top of the x, I take the first and I multiply it by the last. So again, I'm multiplying. So x squared times 24 gives me 24x squared. My middle term goes on bottom, 11x. And then I ask myself, what can I multiply to get 24x squared? So I multiply, but add those same numbers to get 11. So 1 and 24, multiply to get 24. 2 and 12, 3 and 8, 4, and 6. So now, if I try to add 1 and 24 as any combo, I can't get 11. If I try to add 2 and 12 with any combo, I can't get 11. But if I add 3 and 8, that gives me 11, so those are my answers. So on the side, I put 3x and 8x. So that's organizing my thoughts right there. Then I go to the box. I write my first term in the first box, last term in the last box. First box, first term, last box, last term. Then I have 2 empty ones. The 2 empty ones should add to give me that middle term. Well, we just found those numbers right here. They're the sides of our x's. So I get a 3x and I get an 8x. So now I look. What does x squared and 3x have in common? Well, they both have an x in common. Well, x times what gives me an x squared? Well, x times x. Okay, so again, the opposite of the box method for multiplying. Then x times what gives me a 3x? Positive 3. X times what gives me an 8x? A positive 8. If I want to check, 3 times 8 should give me this 24 that's in this last box, and it does. So my factors are x plus 3 times x plus 8. Or if you rewrote it as x plus 8 first times x plus 3, it is the same thing. Okay, so either one of these are the answers. Moving on to example 3. This method does not change no matter what the quadratic looks like. So this time I have a number in front of my x squared. It does not change the process on how I do this. Okay, so this one has no GCF. Okay, so no GCF. So I go straight to the x in the box. Straight to the x in the box. So I take my first term times my last term. 6x squared times a negative 3 gives me a negative 18x squared. My middle term goes in the bottom. Then I need to figure out what I can multiply to get a negative 18x squared and add to get a negative 7. So I list my factors. I got 1 and 18, 2 and 9, 3 and 6. So 1 and 18. In any way can I make them add to get negative 7? Nope. So I cross them off. If I look at 2 and 9, yeah, I want a negative 7, so my 9 needs to be negative. So on the sides of my x's, I get 2x and a negative 9x. Then I go to the box. The box, I plug in first term, first box, last term, last box. And then my 2 middle ones have to add to be my middle term, and I just found that, 2x minus 9x. Now I look to see, what number is 6 and 2 both divisible by? Well, they're both divisible by 2, and then x squared and x have an x in common, so I get a 2x. Then 2x times what gives me a 6x? 3x. So 2x times 3x gives me a 6x squared. 2x times what gives me a 2x? A positive 1. And then 3x times what gives me a negative 9x? Negative 3. And if I want to check, 1 times a negative 3 gives me that negative 3. So therefore, my factors are 3x plus 1 and 2x minus 3. That is now in factored form or intercept form. If I wanted to rewrite it the other way, 2x minus 3 and 3x plus 1, I get the same thing. If I wanted to check my work, I could just FOIL everything back out. The last example for this video, I have a 42x squared minus 20x plus 2. I'm going to do the same thing I've been doing. So my GCF for this problem is a 2. So I'm going to divide everything by 2, factor out that 2. So I get 2, and then what I have left over, I have a 21x squared minus a 10x plus 1. Now I go to the x and the box. X in the box. So I do 21x squared times 1. I get 21x squared, negative 10x on the bottom. What can I multiply to get 21? Add to get 10. Well, let's look. I have 1 and 21. 2 doesn't go into it, but 3 and 7, and that's it. Well, 1 and 21 aren't going to give me 10. So now I need to think of this combo. Now, to get a negative 10, both of my terms need to be negative. So I get a negative 3x, a negative 7x. So first term, first box, last term, last box, and my two side terms that add to give me my middle term go in the empty spots. So what is 21x squared and negative 3x have in common? Well, they're both divisible by a 3x. 3x times what gives me a 21x squared? A 7x. And we don't want to put these terms to be negative because they're our leading coefficients, so we try to keep them positive. 3x times what gives me a negative 3x? Well, a negative 1. And a 7x times what gives me a negative 7x? Well, that would be a positive 1. I mean a negative 1. I'm sorry. A negative 1. So fix that. Okay, a negative 1. So 7x times a negative 1 give me a negative 7. And then if I check negative 1 times negative 1, give me a positive 1. So these are my factors. I get 3x minus 1 and a 7x minus 1. And I put my GCF outside, which was at 2. This is the factor form of this.